I will discuss side by side along with this adiabatic process. Adiabatic. So these two will be the last process. In the previous classes, we have discussed your isobaric process as well as isochoric process. And we have discussed the isobaric process. What is the best way to remember? Isobaric means you have to maintain the constant pressure. The best example will be cooking in an open container, open utensil. There will be perfect example for your isobaric process. And what about your isometric or volume constant? Cooking any food inside the pressure cooker. See, now let us discuss the two main important isobaric isochoric volume constant, pressure constant. No, that is not so important. What is important is your isothermal process and adiabatic process. See, the isothermal process, it is not so important as compared to adiabatic. Adiabatic process is very important. See, that means it has more practical application in our life. Adiabatic process. Anyway, isothermal process, this will be known as your slow process. Adiabatic process, this will be very fast process. Next, the isothermal process. Here, iso means, what do you mean by iso? Equal means equal. Thermal means temperature. Your temperature must be constant. Your T is equal to constant. T is a constant. Temperature constant. What must be the your dT will be equal to 0. The change in the temperature must be equal to 0. Then what is the implication of your change in temperature equal to 0? We have already understood that your temperature is a function of internal energy, or internal energy is a function of temperature. If temperature increases, internal energy will automatically increase. Okay? This simply implies that your du will be equal to 0. Internal energy is 0. Change in internal energy for isothermal process will be equal to 0. And what was the second point to be remembered? You have to remember the equation of state. What will be the equation of state? Equation of state will be P is equal to mu RT, and here this mu RT will remain constant. Mu is constant, R is constant, T is also maintained at constant. Or we can write like this: P equal to constant. See, constant and here we can put like this: this is P1 V1 equal to P2 P2 and we can put it as P2 P2 P1 V1 P2 P2. This will be the equation of state for any equation involving your pressure and volume, and the temperature is at constant. Temperature is constant. Equation P1 V1 plus P2 V2 or P1 V1 equal to P2 V2. This is also known as Boyle's law in right, bro. Next point this is to be remembered. See, we don't have any shortcut for this. See, the chemistry is bro. Exact formula say. I think this is also included in your chemistry. What is the work done in your isothermal process? The work done in your isothermal process will be mu RT. In your chemistry, it may be written as equal. Anyway, what's the new one? And it is all right. Mu RT log of, this is log of V2 minus V1, or this can be also be written as mu RT. This is mu RT log of this is V1 by V2. And what about your log to the base? Log to the base, then I think I have already explained enough about your natural logarithm and common logarithm. I think I don't have to explain it again. So this is this is natural logarithm. 10 half target log to the base 10 half target, this would be our common logarithm of the book. And converting natural logarithm into common logarithm, we have to multiply with 2.303 into this is mu RT. Understood? See, anyhow you have to by heart this. By heart of 0 quality. Anyway, next time last the most important this first point is to be remembered. For isothermal process, it is slow process. You concept when isothermal process, what is the meaning of this isothermal process? Temperature constant. What do you mean by maintaining temperature constant? Body temperature is constant. Can we maintain our body temperature at 37 degrees Celsius? 24/7 se 24/7 ko body temperature maintain taw ngamde increase decrease ram taw idra gyatai ko sina tai di kaino when our body temperature increases means our surroundings we absorb some heat from the surrounding. When we feel cold, when heat from our body is lost to the environment mangi have natra gyatai ko adu mandre hale if our body temperature is maintained at 37 degrees Celsius, that means your surrounding temperature will be also 37 degrees Celsius, and that is thermal equilibrium. There will be no heat exchange between you and your environment. The environment ka nang mabani marak heat exchange to natre body ni se this is AM le natra AM le this is PM le khala jiba. Whenever there is no heat exchange between these two, your temperature of A will be exactly equal to temperature of B ka managani. Only then this A and B are said to be in thermal equilibrium. Understood? And how this thermal equilibrium is related to your isothermal process, that is to be understood. Magi sidali thermal equilibrium ka isothermal process ka se kamaina relate to very simple we have to maintain the constant temperature even though we supply heat is supplied to example point of view temperature of A and temperature of B is 10 degrees Celsius we supply heat to A the heat is supplied to by how much 4 joules apply to let us consider it is applied to the A by 4 joules apply to we know that temperature we know that if it is supplied to a system heat supplied to temperature automatically increases natra. Understood how we go? If it is supplied to the system, then the temperature of the system automatically increases. However, in our isothermal process, we have to maintain at 10 degrees Celsius to maintain the natra. Now, it becomes a temperature temperature 14 degrees here 14 degrees it will be lost to Canada 2 will be lost to our B the lost already B in a cavern. This is 12 and this is 12, but still we maintain our isothermal process, maintain the temperature constant. Do you understand the concept here? And we go in your isothermal process the heat gain the amount of heat gain in your isothermal process will be at the same rate as that of the heat lost to the surrounding, so that a constant temperature is maintained. Understood? Simple concept isothermal process process not very slow process and here the heat gained by a system will be lost to the surrounding in equal rates, so that the temperature of the surrounding and the temperature of the system remain constant. That is the meaning. Understood? I want the heat heat temperature increase in order to remove the heat I must extract the heat from my body. I want the heat to extract to the I body temperature wet towels for it in order to extract heat. Understood how we go? A simple logic in your isothermal process the heat gained by the system will be lost to the surrounding, so that temperature of the system and the surrounding remain at constant value. That is why this is the whole process the very slow way heat to the fast in 1 second 1000 joules temperature of the body will be automatically increases beyond expectation. Hangani ko fast will be very slow with you ne it must require some time to it will require some time to loss heat to the surroundings. Heat to transfer surrounding the transfer to matam khar dakar time it require time for excess of heat from the whole body to the surrounding. Therefore, it must be a slow process. Understood? Next, the last next diagram last. So diagram is this diagram is very important. Pressure का volume हम लोग exercising how to draw a graph between your pressure and the volume for isothermal process. Isothermal process the दिन है it will be a curve and the curve will be less stiff. यहाँ kind stiff हो रही को यहाँ kind stiff हो रही pressure का volume मुझे inverse proportional हो रहा है इसलिए इसे also ना है इसके ना pressure is inversely proportional to volume. If we increase the pressure, volume will be decreased and high level. For any inverse proportion, we have to draw the graph like this inverse proportion only. And how to calculate the slope? Slope of height is very simple. This is dp by dt and this will be equal to minus p by d. This will be the expression. See, we will smarter line to chalo. See meaning से like से आइए हर किसी हो. Man slope height kind of slope height very simple at this point. See point let us consider the pressure to be in a color. At this point let us consider the volume to be in a color. Here Magi can also get that one slope height this will be our slope. And how to find out the slope height we simply take dp by dv. See now this is the mathematical expression and this is our terminology and our formula point of view if you want to find out the slope for this particular point you take the corresponding pressure with corresponding volume. See understood now second point very important if we are to compare to isothermal this is isothermal curve at temperature T1, this is isothermal curve at temperature T2. This is also isothermal process this is also isothermal process however I said we have to compare the temperature T1 and T2 as a compared to such type of question can be asked. Hangiko slope slope height are very simple dp by dv that's enough hangani aduga nang kanigumba sige point don't worry in your question to smile loina full graph ya maga full diagram ya ga dum kaneba full diagram hoita this by this finish anyway sidhe masiko kanigumba if we have two isothermal curve at temperature T1 and T2 then how to compare the temperature T1 and T2. This is the isothermal process that is carried out at 30 degrees Celsius. This will be what temperature it can be asked like this. Okay, so let us find out the logic behind this. If we consider this is constant pressure, what will be the volume here? This is the volume V2 for your T2, for your second process, second isothermal process, we denote the corresponding volume to be V2 and what about your first process? We consider it to be V1 just by looking at the volume V1 and the V2, which one will be more volume process 1 or process 2? You just compare your V2 and V1, which one will be more? V1 will be more natural. V1 is more natural. Now, constant pressure is constant. Pressure is constant. For constant pressure, what would be the equation? V is directly proportional to temperature. From our ideal gas equation, T V is equal to mu RT, and here pressure constant and this RT constant the V is directly proportional to temperature. Greater the volume, greater will be the temperature. This is the conclusion. Okay. See conclusion here T1 and T2 which one will be greater? greater the volume, greater will be the now again temperature natro. Here, it is a V. This is V1 is greater than V2. Temperature T1 is greater than temperature T2. Understood? For any isothermal curve, if we are to compare 2 or 3 isothermal curve, then the curve which is at the top, which is at the top will be at the highest temperature. Do you understand this one? I can see Yareko, sige explanation anyway. Next time isothermal now let us consider your adiabatic process. See, why maru adeko? Adiabatic process ta dine process automatic fast with the automatic fast with the there will be no time for heat exchange. Heat exchange to be matam si phang with the can you give an example here? Example of highway abra adiabatic process है very simple होई ना कोई balloon नंबर दगी कोई ना करेबा sharp pointed pin नंबर तक मतलब माजे कारी ना brush तो रही ना very big होई बरा होई अदो कोई ना vehicle की मागी trip to दगी कोई ना मागी kan grosso को तारी यारो लाखों को तारी तो ना पोखाई दबरो यार तय कोई है जिसे simple होई ना करेबा पता रहे से adiabatic process is the very quick process and there will be no time for heat exchange between the system and the surrounding. The best example will be balloons balloons gas tube vehicles ki koina hapitna cycle ki cycle koina tip lokina tip ek automaton da nuksita tai dana yan dai ko here comes out from the tube of the wheel. Once we take out the maki valve to nang salo ko taradi salo ko idana it hardly takes 2 to 3 seconds to completely empty the gas inside the tube manang da leba gas to khudak to thoki bita 2 or 3 seconds da loibra loi adu banang tholai ba the gas which is coming out from the tube to you put your hand, do you feel hot or do you feel cold? Kari dawi ingro ani nuksi thador kuma damda ke dawi dan kuchi thang da we have cooling sensation am lakra why yaiko adu next example am ko haige koina bicycle am le rekhala cycle sida kamaina ni bicycle sida and when you feel ear se hamse kuma da ke dawi koina fan namjali idna pump do pai le soina koina external work to namjali adu damda pump do ke dawi it become hot koina lakra lai kya dai ko we will be discussing these two particular example with respect to our adiabatic process. Adiabatic process it is the simple process where the process will be very fast, and due to the fast nature of this process there will be no time for exchange of heat between the surrounding and the system. Next, the equation of static this is very important. V raised to power gamma is equal to constant. Gamma is gas constant, gas ratio in height the top. After I say, mono 1.67 natra. This is 1.4. And what about your try this will be equal to 1.3. You should not forget this. Here we will be discussing three very important equation of state for your adiabatic process. All the remaining process will have only one equation of state. Our calculation will be very simple for isothermal process, adiabatic process and volumetric process study. Our calculation is relatively easy, but for our adiabatic process study you have to choose the correct equation of state. Choose the according to the given parameter. Here nangi pressure set. Our pressure P is equal to the mu RT in Now let us convert our pressure P in terms of volume. convert to V is equal to mu RT divided by P. Can we write like this? You just put the value of V over here and this will be equal to kya manani se. Let me write over here. This is P into V will be replaced by mu RT divided by P and this will be raised to power gamma equal to constant. Can we write like this? Now this is constant, so we will not consider this. Therefore, P into this is T raised to power gamma, P raised to power gamma equal to constant. And here P 1 minus gamma and T to power gamma will be equal to constant. So, if adiabatic process is being asked and the variable are pressure and temperature, you have to use this equation. Do you understand? In your examination, it is most likely to be forgotten. Can you remember this? P1 minus gamma T raised to power gamma is equal to constant. If you have forgotten this, you go through like this. Okay? Next, what will be the second? This is A, this is B. What will be the third? We have to convert our pressure in terms of volume. Mu RT divided by V. V mahapasi. Here our pressure P into C volume V. C pressure P will be represented by mu RT divided by V, and this is V power gamma. This is equal to constant. This is T V to power 1 gamma minus 1. Therefore, our third equation will be T V temperature volume raised to power gamma minus 1 equal to constant. So you have to remember these three steps. Understood? And equation of state for your adiabatic process will be quite different from the remaining three process. Isothermal is like, isothermal is like, isobaric is like, volumetric is like. But for your adiabatic process, this is quite different from the remaining. Main formula main equation of state P V raised to power gamma equal to constant, and this can be also further reduced to your pressure and the temperature containing formula P 1 minus gamma T. In terms of temperature and volume, it will be like this. What do you mean by this? These three equations are so these three equations are so in your adiabatic process, the three basic parameters of a gas, that is pressure, volume and temperature, keeps on changing. Do you understand? Let me rewind. This will be the last process of I can repeat it for better understanding. Pressure is a constant. What was the equation of state? Your P V is equal to mu RT and have not true. If pressure is constant, we consider only volume and temperature. Understood? We high with this delay say one parameter remain constant for our ideal gas situation. Ideal gas situation is the three basics is the pressure, volume, temperature. If pressure is constant, then it will be isobaric process, and for isobaric process, the variable will be volume and the temperature. The remaining two next time we see volume constant. The volumetric volume constant, volumetric your P V is equal to mu RT. This is constant. This is constant. It will be dependent on pressure and temperature. Out of the three, pressure, volume and the temperature, V constant. The pressure and the temperature are remaining. These two are directly proportional. Do you understand this one? Next time, isothermal process T equal to constant type. T equal to constant. Here your P V is equal to mu RT. This term remain constant. See, constant pressure and the volume are directly proportional. Out of these three parameters, if one parameter is constant, then another two parameter will have some relation. It may be inverse relation or it may be direct relation for your isobaric, isothermal process or isoporic process. However, in your adiabatic process, Adiabatic process study, there is change of all the parameters. Gyan tabra? Parameter ko ko change tabro. Pressure ju, volume ju, temperature ju ni included tabra. So this is the main point of difference between adiabatic process and the remaining three processes. In adiabatic process, all the basic variable get changed. Simple. In the remaining three processes, only two variables get changed and one will remain constant. Okay. Sim understood already? Now let us see the second very important sima yengasi Waktan se kya mane? Waktan is equal to mu r t divided by, this is very important. Simba pusalo gamma minus 1 idam draba I say anyway 1 by gamma minus 1, and this is p1 b1 minus b2 b2, and here this can be written as mu r, this is delta t. Changing the temperature, this is T1, this is T1 minus T2, gamma minus 1. I don't understand the one, or this can be written as mu r delta t, and this is gamma minus 1. Can we write like this? See, you understood the one, so you don't have to understand how this is done, how this is obtained. You have to simply memorize. Isothermal का adiabatic process study, you have to memorize the Waktan. Waktan तो क्या कहता नहीं? This was क्या है? Mu RT and this is gamma minus 1. Next now we will discuss. Can I discuss already? Slope हम discuss already. After that we will start your calculation. The basic difference between your isothermal curve and adiabatic curve, in your adiabatic curve it will be more stiff I stiff less stiff adiabatic more stiff. Why the slope set your slope becomes your dp by dv even a top. For adiabatic process this is minus gamma, this is p by v na lakro. That means gamma times into minus p by v, which is also the slope of gamma into slope of isothermal tabro. Isothermal process tagi kanana helani se stiff oiba se adiabatic na oiba hen dabra hen. Understood taureko aduna sidana pili sida, if we have to compare the graphical representation between isothermal process and adiabatic process, adiabatic will be more stiff than that of your isothermal process, because your slope for adiabatic process is being multiplied with gamma. Gamma value, all the value of gamma is more than 1 thing value increases. Okay. Now the last point we discuss it we have three different adiabatic process, like process number 1, process number 2, process number 3. Identify the type of gas for the graph number 1, graph number 2, graph number 3. Adiabatic process more stiff greater the value of gamma, more stiff will be the nature of the PV diagram. Do you understand? Bro. Gamma value depend greater the value of gamma, more will be the slope, more will be the stiff. Gamma is maximum, like gamma is maximum for your triatomic your diagram number 3 will be for your triatomic diagram number 2 will be for your diatomic diagram number 1 will be for your sorry mono more stiff will be for your mono has the maximum value like gamma is multiplied to 1.67 multiplied with this slope with it would be more stiff as compared to your diatomic, and number 1 this would be polyatomic, this is triatomic. I actually know about the last and the conclusion of the high simple oina, if you are to compare to isothermal curve and compare to the curve which is at the topmost will have the greatest temperature. Similarly, isothermal gi for your for your adiabatic process the graph which is at the lowest will be for your monatomic and the graph which is at the uppermost will be for your polyatomic or triatomic. That's it. Now let us do your question. Term with question number 12 is there. Question number 12 we have an adiabatic process of the record. Adiabatic process the two gas undergo expansion like this. Here adiabatic process regarding this is pressure, this is volume. We know that the lowest one will be for your monoatomic. Lowest one monoatomic upper one will be for your diatomic and triatomic. Out of the given options, these two will be the second part of our answer. One will be the first part within a trap. This is the you check out of my values. We are given monoatomic and diatomic at the pirava. So we eliminate this option. This is monoatomic at the pirava. Understood? Now this is also eliminated. We have two different isothermal curve whether it must be for different atomicity. One must be for your monoatomic, one must be for your diatomic, and another must be for your triatomic. Here diatomic it must have only one type of graph like that is why we remove this also. Now from this 1 and 2 you have to choose the correct one. This will be our fast graph. This is second, this is fast, this is second. Which one will be true? See one this one will be for your diatomic diatomic. Understood? The lowest will be for your adiabatic process. The lowest graph will be for your monoatomic monoatomic. That means 2 must be monoatomic. So option number 2 will be our correct answer. Understand? Question number 11. I think we have already done your question number 11. Okay. Let's do what about? Let me remind a bit about your isochoric process. Isochoric process Isochoric process. What is the basic? Basic delta V is equal to 0. All the heat isochoric process, the volume will remain constant and the change in volume will be 0. So we will be having your work done equal to pressure into change in the volume. This is equal to 0. If the work done is equal to 0, Q will be equal to plus W. Here, very simple enough. Our heat supplied will be equal to delta U. All the heat given to the system will be utilized for increasing the temperature. Temperature increase to the utilized to high and constant volume it will be equal to mu C D delta T. I think I have already explained this. Explained constant volume with constant volume there will be two different very simply you forget everything, every concept. You just by heart the formula from your convenience. Convenience Q is equal to ms delta T. This is very easy to remember. This is in terms of mass in terms of number is related to moles related. Very simple. Q is equal to instead of mass, we take it is mu. Specific specific heat is sometimes denoted by S or C. I am not C. Depend on we said C delta T is minus E. Do you get the concept here? How to remember the formula? Formula remember to here draw. C is none. Simple example I say 1 gram natraga 5 gram. We have to consider the increase in temperature for a given specimen in terms of mass. Mass the piram taragana ms delta T. And however the sample is given in terms of number of molecules, number of mole the piram tarti, we have to use the second equation. We use the whenever. Example point of view, that's minor low we have three moles of gas, 3 moles of oxygen gas at 20 degrees Celsius. Then what will be the energy required? What will be the energy required to increase the temperature of that 3 mole of oxygen gas from 20 to 21? 20 to 21, the increase of the heat gas. You have to apply this formula. Understand the way? Number the piragana simple enough. Mu C delta. Finish. Mass is replaced by mu. Number replaced by 1. See the specific. This is also specific. Understood? Yareko. The simple enough. Nangasinalo is a isobaric process. The volume is constant. All the heat given to the system will be utilized in increasing the temperature, that is internal energy, and we know that heat is expressed in terms of number tadi mu C delta T as mu C delta T but this consideration is at constant volume we put D over here. Very simple. Understood? Your internal energy is a function of temperature and height. These two will remain constant. CB4 monoatomic क्या आता है? हाइड्रो क्या आता है? CB4 monoatomic काबरे अगर I just call back and I'm not we call Shadi or Shibai to our tablo. CB4 your Nangi can always say diatomically it would be 5 by 2 our tablo. This is fixed balloon throw. This is constant the internal energy is directly proportional to temperature. I have the conclusion the C relation. What I want to conclude here is you forget everything, and if internal energy is being asked, you simply apply mu Cv delta T. Number of moles, heat capacity into heat capacity or specific heat at constant volume into changing temperature. That's all. Yarba? Question number 11. The temperature of 5 moles of the gas which was held at constant volume. See question there. Internal energy you must apply at constant volume mu Cv delta T. Mu is given, and what is the change in temperature? 20 degrees Celsius. 120 dagina 100 lata di kya ta 120 110 120 20 record delta T is given as 20 aduga mana puthwai si kaino total heat capacity for the gas at constant volume. The change in internal energy is IT joule. Si pire yaar aisi ho chalo yaar bhai si khar na pi do number of moles to si hayani ko yaar se mana holo si CB holo finish no even that mo chalo si ka si daga. Question number 15. Question number 15. So I is nangi air fill in the tube of a wheel of a car at 27 degrees Celsius at 2 atmospheric pressure. If the tube is suddenly burst, the final temperature of the air will be kya ta dagi have new. Adu sida mana piri se kai kai piram me. Kana ki malam da piri me se temperature is given, pressure is given atra. Understand the uma miko? This is adiabatic process. The adiabatic process will be very fast process. Yang fast process one example oina nangi tip tire pokhai ba. Gari ek thoro madagi wheel basin ay kami ko. Cycle ki tip tire ogera, car ki ogera, ikang hog dana natraga balloon nama do koina machine to mom pa tang thiyo kan kai ai dana. Adu ju kai ko that is nangi kan oi di ba gari ba ki adiabatic process wo di ne. I am saying that the home job male adiabatic process ta there will be volume expansion and there will be volume compression la kani ko adu jang tang hairo hai bring ke kai um matam da brush to matam da is this is the volume compression or volume expansion la compression la si nang balloon nam lai dina tra balloons the even air flow or fill it is under a fixed volume, fixed compartment. Now you release it. It will come to the external surrounding. External surrounding by volume. It is released. So you have to consider the volume expansion. This is volume expansion. Magi achin ma congested jaga amadagi ne from your congested tube tagi kana hoyo sa congested tube tagi it comes to the surrounding the lakro bro congested tube tagi surrounding the lakoni na kari hoyo no batare sa it must be considered as volume expansion. Ya bro, forget everything nang ningjang you just kano ko ningjang ho whenever there is nanging asagi kaneba like tip brush to bata the volume expansion. Yeah, and what is the consequence? Magi volume expansion I thought V2 minus V1 say will it be positive or negative? V2 is the final volume, V1 is the initial volume. Volume increases na tro. Volume je opena expansion ID volume increase habeneba. This will be positive tabra. This must be positive. That means your delta V will be positive. See positive taramina your work done will be also kya tarani V delta V. This must be also positive taraba. Positive tar. Kya tare? Now mathang gamla asiko. Our delta Q is equal to delta U plus W. Fast of thermodynamics को यारी से सीधी क्या आता है for your adiabatic process this will be equal to 0. There must be no heat exchange. Heat exchange समता लेबिया दे है को for your adiabatic process heat exchange must be equal to 0. 0 चलेगा this is delta U plus W umlakra like को delta U will be equal to minus W umlakra minus W umlak को अदु here this would be negative of positive umlakra and this negative umlakra. What do you mean by this negative? Temperature decreases. Internal energy से decrease तो वह ना था the internal energy decrease तब का भी कोई की temperature decrease तो रोमिना we feel cooling senses यार ना ना नुकरे नेट से लगे ये मुसोबा ना second उसी कोई की class 9 10 का कोई लोई तो पूरा तो कोई यार तो ये देखो कोई की friends कहीं की मोई की cycle से की नुकसी था तो भी तो यार क्योंकि जब वो मतलब दा मागी the air that is coming out from the tube sac कोई ना खेत से cycle मतलब cooling sensation आउरा. This is because of this explanation. The temperature will be decreased. In your adiabatic expansion, the temperature decreases. Don't forget this. In your adiabatic expansion, temperature decreases. That is why when the tube of the wheels are brushed it produces cooling sensation. Next, the second opposite opposite I will not be going through like this. Again, you just consider the reverse in the lower ziko. Air fill the pipe pump. pump sina swaina halitra sum hanjali ko adu itadi mag air sikla di we know we have to take the air from the surrounding di laura and it is to be fit inside a compact volume umada sai sida di le volume je very volume je yana surrounding volume je it is the largest within a jar and it is now kariba sa fit inside a very small volume umada maje by inyau minyau to hapsan duine ba gyan tare ko that is nang kari hagi air fill hai ko tara gadi that is compression compress away hai na tro fine namjali na tro namjali ne ba adu fill tawlo tung da kedawi pai ba kan sarak ta bra sare gyan tai ko volume expansion the cooling formula volume do smaller or hinta rati ke dawrani sagi air do surrounding like kan we consider it to be with a greater volume omlai khanga dini we consider the air in the surrounding to be at a greater volume khangani ko and now this greater volume the air say it is fitted inside smaller tube to fill tawre so that volume decrease taw say only when there is compression la kan thokuna to yai koi hari se adu ita simple oina nang kamai khang batare in your adiabatic compression se the ke batare adiabatic compression the your temperature increases delta U become positive or therefore it will produce heat produced tawi nan pam to halo ro no pai kan ke dawi sabra sadabra sai adna forget this si logic se roi ko ko si lon mak step by step ta khang lai ta it will be very hard for you to remember all this. Okay, you simply memorize the utare and the adiabatic expansion are ko adiabatic expansion is the in your adiabatic expansion or adiabatic expansion means volume increase hai ni ko if the volume is increase volume to increase to ko kan di ke do batawa nangi temperature decreases over the next adiabatic now idra se adiabatic compression the volume se ke ni decrease na tro volume decrease na temperature increase nungsit hadok matam dana temperature handari nungsit hano matam dana ke dawi temperature increase tam adu now let me ask one simple question ama hange hybrid ko kogi thermoflux madane thermoflux is ke what is the system that is applied for your thermoflux flux the heat is not allowed to exchange with the surrounding exchange to we are yati cold water hapagna it will remain cold hot water hapagna hot water tum oil idira lege now let us take a hypothetical condition amalorasi where you put cold water hape khalaje cold water hap is the you shake it nang sigi thermoflux mas finally besta slave so this is cold water nata sigi cold water se you shake it now swaina ni pata raga dikhe will the temperature remain constant temperature je constant hoga natraga will the temperature be increase or decrease hadi water se see koi 0 degree de lere khala je ba hadi sina there is no heat exchange nang heat exchange am to tawga di ha bane heat exchange is equal to 0 heat cannot be exchanged with the surrounding in thermoflux so this will be considered as adiabatic process natro heat exchange tawga the adiabatic process ne ba adu di nang is de se temperature will increase karigino you are doing some external work say on the system to manatra on the system to tadi if work is done on the system we have to take the work to be kai lawi se negative negative lo re ko in short kamai have tare the work done on the thermoflux say it will be now converted into heat and that heat cannot be exchanged with the surrounding ka exchange the way they therefore temperature of the water inside the thermoflux will increase automatically gyan ta ba man increase the when 0 le nam dagi 10 degree increase to ko 0 dagi it may be 0.5 or it may be 1. Temperature increase. Anyway, let us come to our question. Question the last. Understand it already? As you see, question is that the cooling sensation put okadra traga nangi temperature increase okadra. Question number 15 da volume expansion la na traga volume enora compression la. Question number 15 se volume expansion na tro. Ado di mana pyramid kari pyramid. Your pressure is given. Pressure pyramid. Temperature is also given. Then what is the relation that is to be used for our temperature and the pressure for adiabatic process? Pressure is the 1 minus gamma T minus E na tro. Sini ni simha putu dia ro. Ai ju he kawi ko. Is it true? This must be the equation of state. Chumeko. Adiabatic process ka mana ilise. By equation of state haraga T V to power gamma minus 1 hai maga number C the P is T gamma raised 4 gamma P 1 minus gamma equal to constant nama tabra. Time. Sikhangi ko. Now ay nahanging si kaya nahanging no. Magi what was the pressure? Initial pressure P1 divided to kya hoy log ni? The air was inside the tube na tro. Inside the tube limatan the pressure was kya hoy log 2 atmosphere hoy bra. Now it comes to the surrounding with the temperature of the surrounding is usually considered as 1 atmosphere. 1 atmosphere Niko. Very simple way now. We have to put like this for your better understanding. Sina P1 sina kay laura sige. 1 the leaves na this is inside kini na kalasi. Sina outside kini na kalasi. Kay ko. Inside pressure the cannot P1 2 atmosphere. Aduga P2 outside kidi 1 atmosphere. Yara ba? Temperature T1. This is 27 degree. This is 300. T2 100. Yes, T2 100 niko. Ado mana kaya pyramid gamma si pero kya pyramid gamma is equal to 1.5 ampere. Si kana karam boy dino sa identify the gas. Khangte ai ju khangte ko standard hoy di 1.3 ai tara gadi mono tai na. At the 1.3 is in the sound, this is maybe hypothetical question. For calculation point of view, real life I am not the scientist, so I don't know whether this gas exists or not. Okay, go. What is P1 1 minus gamma, P1 gamma, this is P2 1 minus gamma, P2 gamma. And see gamma is also if this is square, then we have to take the 1 by 2. Square along 31 by la idna. Now can we put like this? This is gamma. This is gamma. Do you understand this step? So the square later 1 by 2 1 by 2 la idna. Yeah, ko. Adu chama na si happy le. This get cancel out. P1 की value क्या ना? Gamma value क्या ना? 1.5. T1 value क्या ना? I na then I put it on a cover deva. You should convert the given temperature into Canada on the no and after that you have to convert it again into tricky the one with the Minus left is 1 by 3 record. This is T2. You put the value. You will get in terms of Kelvin the fungani, and that Kelvin has to be converted into Drigi the one. Next question. Question number 16. I hint khak pi ge no atai remaining gon lo ho chau khia hai ni istemana pi ri je ke no the volume of a polyatomic gas and the polyatomic the 1 by 3 is 1.33 ni ko ya ko compressed analytically to 1 by 8 of the original volume, that is V2 equal to study of my pressure ko volume pressure ko volume ko pila me, so can I shorten it by this equation minus term similarly P1 P1, this is gamma, and this is P2 this is gamma. Can I write like this? Mani ibya yare ko maram the pressure ko volume ko piram manatro piram ko from the earth. For your question number 16, the variable that is mentioned in your question number 16 is pressure and volume, so we are going to use the main equation of step P raised to 4 gamma. Yare ko kishna ka khanga ni answer ko pata ro sile manatro. You put the value like this, and gamma ki value is 4 by 3 na ikatro. You try this at your home. Any answer to 16 pinota 16 pinota ni ko. Try to this to I do examination ko. You want get cancel out. Question number 30 is simple hybrid. Two questions there. Difficult sunate, the easy sunate, moderate niko. Question number 30 is hybrid. question number 30. The 1 mole of ideal gas goes from initial state A to final state B via two processes period. First, it undergo isothermal expansion. Number from volume V to 3V. Volume V dagina 3V am chatprai ni diagram su la labra. Dama la me. 2V ka pa sa labu maleko. Yay. Understand that? Mana aham sali je isothermal expansion naman chale. Expansion means increasing the volume. Yare ko. Next time ko ipile mana sali je, and it undergo, then its volume is reduced from 3 volume to V naught at constant pressure. Constant pressure the second process na, first process na isothermal, second process na isobaric process. Okay, and you have to choose the correct diagram. Correct diagram select the one. Adu ye mose asur kana ta sida ye mose. Can your option number 1 be our answer tabe agata yaro kari kino why? Because first process must be increasing the volume volume expansion although there is increase in the volume se a dagina sibukti volume se expand taura tawi adubu it cannot be kana we say our isothermal process where the isothermal curve must be it must not be for isothermal process, it must be curved, and here it is written as straight line, it is drawn as straight line in Pibra. So our option number 1 is eliminated. Yare ko. Next na mo yung simu obya agata. Number 3 je. This is also eliminated because the volume je decreases obra. V and this is 3V bro. Our volume compression volume decreases. Sina compression mag yadavi criteria je habira moga. This is compression and compression la kadu ko neba. And expansion to ko do compression hoita this is wrong. Adu do we have this silebra? We don't have this type of Firstly, there is volume expansion to me. And what about your isobaric process? Isobaric process that our pressure must be constant. That means the graph must be perpendicular to the pressure axis. Pressure axis the perpendicular with the graph. The option number 2 must be correct answer. See the perpendicular with it means decreasing pressure is decreasing from single pressure. So this is pressure P1. This is pressure P2. P1 and P2 are quite different. We are not maintaining our given condition. Pressure must be kept constant. Maintain the so your diagram number 2 is our correct answer. Yeah, and understood the next time we see. I can know what about question number can you say what about question number 36 and 36 से मरु है आई नहीं खाए तो कॉब उनको आइसोथर्मल प्रोसेस का एडाबिलिटी प्रोसेस का जो है हमारी कैरेक्टर जो ऑलमोस्ट अदम कंट्रास्टिंग होने चाहिए इधर slow process fast process dagi mag curvature na amna less stiff amna more stiff like na contrasting japani na question can be asked from combined question can be asked from your isothermal process and adiabatic process. And khangadu se in your isothermal process the only kana pressure ka volume ka change ta wipo aduga however in your adiabatic process the pressure, volume and temperature, all the 3 variables get changed. Question number 36. A monatomic gas at pressure P having volume V expand isothermally to volume 2V. One isothermal expansion I have not volume से कितना दिख रहा है वो expand हो गया. What was the initial volume? The VM नहीं था. Now मतलब the calculation 2V mana piri se ahan bada se piri se very simple oina we have an isothermal expansion. Isothermal expansion from volume kya bono. Let us read the question. Question 36. The aerodynamic gas at constant at pressure P, pressure Pm ले रहे हैं, volume Vm ले रहे हैं, अतो isothermal होगी temperature T, यानी को अतो it expands to बाकी क्या नोसी क्या आता है temperature हम प्रेशर हो जाता है. Let me remove this temperature. Mana pili sta we have isothermal process sama pili isothermal expansion. Volume is expanded from kaya se kya abu dhire na to dhire expand ho rekho. Next the second process ta kana tagi 2v tagi na 16v da mu adiabatic process mu expansion thobra. So do we know the pressure P2? Hangde. Do we know the pressure P3? Hangbro, hangde dana. At the first when we are being asked to find out your P3 hangana drop. Question at the paring woman is monoatomic gas ki aham the pressure PM number drop. From the pressure P, it is now expanded isothermally to volume 2V. Since isothermal expansion or there must be decrease in increase or decrease in pressure malakadra. Pressure to decrease to do not. Yeah, that understood to one before I said. Here pressure and the volume is inversely proportional for isothermal process. Isothermal process that if volume increases, then pressure will decrease. From the diagram space the pressure P this is more natro. This is more. See the lesser will grow with the bro. Decreases natro. Volume increases, pressure decreases. Along the x-axis, volume increases. Down the y-axis, pressure decreases. Okay. Now, from our P2 it undergoes adiabatic expansion. Pressure is further reduced to P3. So we are being asked to find out this P3 value one. Understand that? Now, for your isothermal process, for your isothermal process our pressure is what must be the equation of state? P V is equal to mu RT. This is constant, so it will be P1 V1. What is P1? PM. What is P1 V? What is our P2? P2 cannot. This is P2. And what is the P2 V naught? 2 V apo. V get cancel out. P2 की value से क्या आता है? This is P divided by 2. P naught and P by P मान लो. P by 2. इसका P ले ले. This is P naught by P by 2. यार बा क्या करे को? Now मतलब दूसरा कनेक्ट है ये. We have to find out the pressure at this point. So the pressure follow after next time we want adiabatic process. Adiabatic process the pressure का volume of here we have to use this as P2 V2 P2 में half V2 की value क्या नो से 2 Vm लगता gamma. Understand the woman? What is the volume at this P2 region? 2 Vm libra. And what is the pressure at this P3? P3 we do not know it. P3 into. And what is the volume here? This is 16 lakra. This is 16 gamma की वैल्यू क्या आती है 1 की वैल्यू 4/3 की बा 5/3 की को2 to power 5 से क्या होगा finish Terus sudah sih kok, ayo yang mungkin aku yang takut.